Okay, hello everyone, and welcome to today's DevConnect webinar. It's my pleasure to chair our session today, and we have two excellent papers to discuss, and these papers will offer some good insights into connectivity and social sexual assets in India and Senegal. Let me first thank our two speakers, Gwen-Jirō from University of Osaka and Anshika from Shiv Nadar Institution of Eminence. I want also to thank our discussants, Jean-Baptiste Guiffard, Maria Hernandez de Benito, and Samantha Rawlings. So for the presentation, we'll have these two presentations, and each one will be about 20 minutes. Then we'll have some discussants, 10 minutes, and we also welcome questions at any time using the Q&A and the chat that you can find at the bottom of your screen. And we will try to address as many as possible during the discussion part. So without further ado, let's move to our first paper, and let's welcome Anshika Mathur for the first paper.
Hi, hello everyone. I'm Anshika. I'm a PhD student at Shiv University, and today I'll be presenting the paper titled "Connectivity in Crime: The Impact of Broadband Availability on Sexual Assaults in India." This is co-authored with my supervisor, Professor Gitanjali. Thank you everyone who is here and for joining in, and I look forward to the comments. So this paper is motivated by the fact that proliferation of internet access has fundamentally changed social interactions, economic activity, and information dissemination. And while digital access provides opportunity for empowerment and accumulation of social capital, it can also lead to adverse social consequences. One of them is that it has heightened the demand and exposure to illegal pornography. Evidence on how consumption of such content affects human behavior largely comes from lab experiments in psychology, and we get ambiguous findings. While some experiments report no effect or even a decrease in sexual aggression, other finds that violent pornographic content increases sexually aggressive behavior among males. Whether these effects carry over to the real world remains an open question. The existing empirical literature primarily comes from developed countries and suggests mixed context specific findings. For instance, Kendall finds that broadband expansion reduced rape rate in US, and Digman document a decline in reported child sexual abuse in Germany, suggesting a substitution effect through online content. In contrast, Buller and co-authors find that broadband expansion in Norway increased sex crimes against women and children. We extend this literature by showing how internet access may exacerbate gendered harms in traditional setting. In this paper, we study the impact of high-speed internet availability on sexual assaults against women in villages in rural India. We hypothesize that easier access and faster circulation of explicit content online may lead to an increase in cybercrimes and sex crimes against women. Rural India presents a compelling setting for studying this. First, because it has traditional norms, it has high youth unemployment, low digital literacy. It is also one of the largest consumers of online pornography, despite ban on certain websites by the government. Moreover, there is a strong emphasis on female virtue to the extent that even the perception of safety can influence women's labor market outcomes, educational attainment, and their age at marriage. To our knowledge, this is the first study in a developing country context to examine the link between broadband expansion and sexual assault. Our works build on mixed evidence from developed nations by showing how internet access may amplify sexual violence in a remote community. Second, we provide evidence on new evidence on online forms of abuse that disproportionately target women. We also contribute to the broader literature of the socio-economic effects of internet. We try to show whether internet access can lead to some employment generation, and whether controlling for these effects might attenuate some of the possibly attenuate some of the harmful effects which we find. And lastly, we contribute to the data space by constructing a novel geocoded village-level data set of broadband availability and join it to granular measures of crime, internet speed, and multiple administrative and survey data sets. Now, since internet availability is typically endogenous, that means that urban areas with high income and greater population density tend to be prioritized for connectivity due to their commercial viability. We address this by leveraging spatial discontinuities in broadband infrastructure introduced by the rollout of BharatNet. So, BharatNet is the world's largest rural broadband initiative. The goal of the program was to reduce the rural-urban divide by providing fast internet speed at the household level. To understand how the program was implemented, it helps to know a little bit about India's administrative structure. So, India is divided into states, and India is divided into states, and then each state is subdivided into districts. Within districts, there are blocks, which serve as a third administrative unit. So each block contains several gram panchayats. Gram means village, and panchayat means council. So basically, each gram panchayat or a village council governs between 2 to 3 villages. The aim of the program was to connect all 250,000 gram panchayat to a broadband connection. And the rollout was staggered. The initial target was to connect 1 lakh gram panchayats in phase one, followed by another 1 lakh, and lastly, the remaining 50,000. The rollout was delayed, and due to lack of progress, the program was rebranded as BharatNet in 2015, and a new implementation strategy was adopted. So now, under BharatNet, allocation of which gram panchayats are to be connected followed a cost minimization algorithm at the block level. That is, selection was based on minimizing the additional length of optical fiber required to connect a gram panchayat within a block. This rollout at the block level created discontinuity in broadband access across neighboring villages which lie at the block boundary. This is central to our identification strategy. Also, the infrastructure was publicly subsidized, allowing private telecom companies to access it at low cost. And these providers installed over 1 lakh Wi-Fi hotspots across the country. By 2019, the first phase was complete and the 1 lakh gram panchayats were connected. For our analysis, we have the names and coordinates of where these connections were made, which allow us to precisely measure which village gained internet access through this broadband connection and which did not. I'll explain the construction of the treatment variable in a bit detail now. So first, what we do is we web scrape the BharatNet coordinates from the BBNL website, and we map them to block shape files, which we obtain from Shrug. So blocks are then characterized as treated versus untreated based on the BharatNet connectivity. This is shown here. And the intersecting boundary between them is the boundary along which broadband access changes. So basically, this is an intersecting boundary, and we'll be comparing villages that lie on either side of the boundary. To get the treated villages, we simply join the BharatNet coordinates to the village polygon, and we get our treated villages. Now remember, a gram panchayat was to be connected, and a gram panchayat governs about 2 to 3 villages. And only the village where gram panchayat office is located got the connection. So simply comparing all the villages in the untreated blocks to the treated gram panchayat villages in the treated blocks would bias our estimates, because gram panchayat office villages may systematically differ from other villages. The appropriate control group should also consist of gram panchayat office villages in the untreated blocks. To identify them, we conduct a fuzzy name matching exercise between gram panchayat names and village names. So basically, this is our intersecting boundary. On each side of the boundary, we have the villages. We identify the treated villages from the coordinates, and the untreated villages, which are the gram panchayat offices in the untreated side. And we'll be comparing villages that lie within 10 kilometers from this boundary. And since India is large and we have the entire boundary, we cut the boundary at every 25 kilometers so that we are comparing within a justifiable spatial range. Uh, Coming at our outcomes of interest, for sexual assaults, we consider 3 data sets. Our first data set captured media reported sexual assaults incidents. This is sourced from GDELT project, which is accessed by Google BigQuery. So GDELT monitors all the online news media from across the world in over 100 languages and uses machine coding to classify events in real time. This data set provides coordinates of reported incident, so we map the events which are coded as sexual assaults to the village Shiv files. And to ensure that we focus on civilian crimes, we also consider a measure by excluding events which include any state actor through text analysis. Um, Lastly, this is one data set. Second, although we'll be comparing neighboring villages within 10 kilometers, we cannot entirely rule out potential media reporting bias. To address this, we supplement our analysis with first information reports, that is FIRs, which are filed in police station. We do this for the state of Odisha. So from the Odisha Citizen Portal, we web scrape the FIRs which are filed in the year 2019. We consider Odisha because it has publicly available data of FIRs on its website. We then use Google Map API to geolocate the police station and map them to the respective block. To give the context, this is the map of Odisha, which is a state in India. Here, this is the treatment boundary. We'll be comparing police stations which are located on either side of the boundary. And to show that Odisha is not an outlier in terms of sex crimes against women in India, the Odisha lies somewhere in between. It's neither one of the states which has the highest crime rates, sex crime rate against women, neither one of the states which has a lowest crime rate. And we also show that the RD manipulation test kind of goes through. And lastly, the data which we did not have to web scrape is the district level sex crimes, which is available available at National Crimes Reports Bureau, and 2022 was the last year when this data was updated, which gives us a district level count of sex crimes. To see how internet could affect sex crimes, we show that fast internet access facilitates the availability and circulation of explicit content, which could drive criminal behavior. Additionally, the anonymity offered by the cyberspace lowers the perceived risk of identification, making it easier for individuals to engage in such acts. If this is the case, we should also see an increase in circulation of such material and an increase in cybercrimes against women. For cybercrimes, we use the same 3 data sets. The only difference is that unlike sex crimes, which are cameo coded in GDELT, the codes for cybercrimes are not available. So we use a text analysis approach wherein we search for words like cyber assault, cyber hate, cyber harassment in the news article to create a proxy of media reported cybercrimes. We again use the FIR data to get the count of FIRs filed under the circulation of obscene material, and we also use NCRB dataset. We consider 2 implementation questions. First, whether BharatNet was successful in providing internet availability in the villages. For this, we use Antyodhya village survey done in 2019-20. Next, to assess whether connected villages experienced faster internet speed as promised by the program. We use the Ookla data set. So we interpolate the data to Indian village. So Ookla data sets basically provides this is a speed test company. So they provide the mean special tiles of mean upload and download speed in megabytes per second. We interpolate it to Indian villages and calculate the mean upload and download speed in a village in megabytes per second. Lastly, to see who uses the internet and or who is online, we use the time use data sets to get a proxy of number of minutes spent in mass media activities, and whether there is a difference by gender composition, age composition, and so on. And lastly, to to complement the literature that internet generation can lead to internet access can lead to employment generation. We use the periodic labor force supply survey and to see if we can get some employment effects and whether controlling for these effects attenuate our previously observed effects on sex crimes. Uh, our estimation strategy follows a special regression discontinuity framework, and in the baseline we use a local linear RD polynomial. In specification 1, YV is the outcome for village V. BharatNet equals 1 if village V got the internet. The function of geographical location is the RD polynomial that accounts for spatial heterogeneity. The seg-V are segment fixed effects taken at every 25 kilometers along the boundary. Lastly, these boundaries in some cases could overlap with other administrative units, such as assignment to different states or district. That may differ not only in terms of broadband connectivity, but also in terms of various legislative, executive, and judicial resources. For account for these differences, we include district fixed effects in our primary specification denoted by delta D. The key identification assumption here is that all relevant factors beside broadband access vary smoothly at the BharatNet boundary. We check for this, but we do not find any discontinuity in sex ratio, literacy rate, employment, population, and other geographical characteristics. For the district level data, that is the NCRB and time use, we use a simple OLS strategy. I'll quickly come to the results. So this table presents the estimates from specification 1 for 3 outcomes: the level of media reported assaults, the year-on-year change in assaults, and the assaults per 10,000 population, each estimated using 2 alternative bandwidths, 10 and 25 kilometers. We use GREL data, and the standard errors are clustered at the block level. We find that broadband expansion led to an increase in media reported sexual assaults. In panel 1, column 1 shows that within 10 kilometers bandwidth, media reported assaults rise by around 0.5%. Column 2 shows that year-on-year growth rate increases by 0.52%. And column 3 shows that assaults per 10,000 people also increased by 0.65%. We also expand in panel 2, we also check by excluding events involving state actors such as police, military, or government, and we find consistent result. Coming at the FIR data, again, here also, so here we are comparing police stations on either side of the boundary, and we find an increase in FIRs related to sexual harassment, stalking, assaults on women in treated villages. We also find an increase in FIR related to circulation of obscene content. One thing to note here is the coefficient on rape is not statistically significant, but as per the Supreme Court mandate, FIRs which are of senior sexual crime nature and on terrorism cannot be displayed online. So this merely is because of a power issue, because we do not have enough FIRs of such crimes reported online, and they're just marked as the IPC section codes are not available for these FIRs. We find
sorry, Anshika, for interrupting, but you still have 2 minutes, about 2 minutes left on. So we make sure we have enough time for the discussion. Yeah, please go ahead.
Sure. We find consistent results in NCRB. We find also consistent result that there is an increase in media reported cybercrimes, increase in cybercrimes related to violation of privacy, creation of fake profiles, and obscene material circulation. And we also find that the program did actually provide meaningful internet speed. The treated villages on average had 7.18 higher probability of having a broadband and 7.2 higher download speed in megabytes per second. We find that males are the one who are actually using the internet. Unfortunately, the amount of time spent by rural females on internet is very low. The mean is very low, and we do not find any change in females which are able to access the program. We find that there is some scope. There is an increase. There is an employment generation. And when we control for these employment generation, so basically we incorporate the employment generation as a control in our NCRD specification, and we find that most of our estimates kind of reduce in half a size, and some of them kind of lose their statistical significance. We do a bunch of robustness tests, but I'll not go through them. We try and address that reporting bias is not the one indicator which is driving our results. The one limitation of the study is that although we find that controlling for employment decreases some of the harmful effects, we cannot point out to which channel is dominating. If women are stepping out to work, they can afford safer travels, which can reduce the crime against them. However, the literature also suggests that if women step out more, they face more public sexual harassment, which of the and can also lead to a higher meeting and matching rate. Which of the effects dominate remains an open question, and we cannot comment on that. Thank you.
Yes, thank you, Anshika, for the great presentation and for keeping to the time. We can move now straight to the discussion. So I don't know how you would like to proceed, our three discussants.
You want?
Yeah, so if you want, you can start, Jean-Baptiste.
Okay.
Yeah.
Okay, so thank you very much for giving me the opportunity to read the paper. So this is a very ambitious paper, and I think that the paper would benefit from a sharper prioritization of its core contribution and a clearer hierarchy between the main results, the mechanisms, and the broader interpretation. So the paper seems to move rather quickly from internet access to pornography exposure, and from pornography exposure to sexual violence. And in its current form, this mechanism feels too speculative relative to the evidence shown in the literature. More broadly, I think the paper should engage more seriously with alternative channels advised in recent work on digital access and gender norms, including cultural change, changing reporting behavior, shift in women's visibility and agency, and involving social norms. I think it can, these mechanisms may partly complement your analysis. And I am thinking about this topic about a paper of Daniel Perez-Parra and author on fast internet and women identity and female genital mutilation in sub-Saharan Africa. Also, there is a central interpretational issue. This is whether the paper identifies an increase in actual violence or an increase in reporting and visibility. This concern arises for media-based outcomes, but also for police and administrative records that you have in your paper. Better internet access may increase awareness, access to reporting channels, media attention, and the willingness to report sensitive crimes. So this is particularly important in a context where gender-based violence is likely to be underreported ex ante. So yes, and I think the identification strategy needs to be clarified and defended more convincingly. I was left with several questions. Who exactly belongs to the control group? The villages you have in the control group, will they be connected later or not? Whether delays in rollout can really be treated as plausibly exogenous. Whether treatment exposure is homogeneous at the village level, and how the timing of treatment enters in the empirical design. In fact, you have one period in your model, but I need to be. I think it needs to be a little bit more clearer.
You're
Wheeler,
muted.
yeah, you're muted. Yeah.
Sorry, I think at another paper in the UK that is looking at the impact of fiber broadband. It's a paper of Koutroumpis and author. I think it's a nice paper as an inspiration, but we can talk about it maybe later.
Shall we go next?
Yeah, Jan, you're muted. Sorry.
Yeah, Maria. Yeah, you go ahead. Yeah.
Okay, perfect. No, so I mean, I coincide with a lot of the comments made by Jean-Baptiste, and also congratulate you on the paper, because I think this is a very understudied question. What are the negative consequences that access to internet might actually have? The first comment was also on the framing. The first part makes it sound like this is a paper about the negative impacts of access to pornography, but actually the channels of internet access, could be that men are participated in internet forums with a lot of anti-women's rights content. It could be access to information on how to assault women, mental health outcomes. It's not clear, so I would reframe that a little bit as well. That said, I don't know if it could be possible to look at maybe Google Trends on pornography or something like that could reinforce the mechanism. On the identification strategy, I was also a bit confused by the definition of treated villages, because there was a line that said that only the headquarter villages within the Grand Panchayats were connected. So I don't know what share of the treated village is that. Does that imply that your estimates are a lower bound? Could you look at impacts only for the headquarter villages? I think a bit of a discussion there would help to understand the interpretation of the coefficient. And then you have the falsification test to test for pre-existing differential trends on the outcome variables. First, I think that table came a little bit too late, so I kept wondering throughout the paper, and then you presented it after the results, so I think you could move it before. And second, that table, at least the way I understood, did show some statistical significant differences. It's table A9, and I think this needs to be a bit more addressed in the paper, not just one paragraph before the conclusion. But yeah, thank you so much. I'll pass it to
Thank you, Maria. Maybe other comments, questions from Samantha?
Yes, so actually many of my comments were also sort of echoed in those that have already been made. Again, I do want to also say, it's quite an impressive just data collection and matching exercise here. I mean, you can really see the effort that's gone into this to construct a really interesting data set that you can hopefully kind of exploit to answer this question. I think I was also quite a bit unclear on the treatment and control issue. And it wasn't always very clear, the estimation strategy. I think the comments, I wrote some comments on the draft that I'll send you, and I think in places the language is maybe a little bit loose. So I think you do need to be a bit clearer about how this sort of GP level rollout kind of actually mapped onto village level treatment. And I think at some point I was thinking kind of there seems to be some heterogeneity in actually exposure to the treatment and who was getting it, and it just sort of, I just got a bit confused as I was reading the paper. And I actually also wasn't quite sure about this issue of sort of ongoing, this process is ongoing. So there are some control villages that may now be treated, and it wasn't very clear this third phase that's still ongoing, whether any of that ongoing treatment overlapped with your data. So I think a little bit more discussion to ensure that there is a clean treatment and control group, because this rollout is ongoing, could also be clarified a little bit in the data. And then I think on the mechanisms, I think whilst potentially plausible, I think there's probably trying to say a bit too much or a bit too strongly based on the evidence that you have. I wasn't very clear when reading the paper what the employment story was, and how by including these district level sort of association between employment and outcomes, how that attenuated the effect. Why that? I just wasn't really clear on following the arguments that you made in the paper, and I think a bit more discussion around how you measure internet use when you're looking at the time use data and how it's inferred could have also helped the reader to understand what you're doing. And then I think finally my other question was around reporting bias. So you do talk about reporting bias, but I'm not sure at the moment you're sufficiently addressing it, particularly that there are some types of violence that are more likely to be underreported, and that when you're relying on media reports or reports to police, you're inevitably picking up the more extreme forms of violence. So what's happening to these less extreme forms of violence that you're potentially not capturing? So I think those were my thoughts that I'm not, as well as the agreement with the previous comments as well. Thanks.
Okay, thank you. So yeah, Anshika, the floor is back to you now if you want to respond to any of the comments and questions.
Yeah, thank you for all the comments. I just respond to the one on connected treated villages and untreated villages. As I said, that headquarter villages treated. So there's a question on how many villages are headquarter villages. So basically there are like 6 lakh villages, and a Gram Panchayat typically governs about 2 to 3 villages. So among 2 to 3 villages, there would be one headquarter village which receives the internet. And I do agree that there can be spillover effects to the villages, other villages which it govern, which kind of will then give, which kind of will say that these are the lower bounds or lower bound estimates which we kind of get. And I love to thank you, Professor Rawlings, for sharing such detailed comments. And I love to see the comments on the draft and then go through the writing carefully if the writing is loose in some aspects. Thank you.
Yes, thank you, everyone, for this first stimulating session. So we can move now to our second presentation, and I'm pleased to give the floor to Gwen-Jirō. So please go ahead.
Thank you, Eliane. Let me just share my screen. Can you all see my screen now?
Yes.
Great. So, hi everyone. I hope my connection was still stable. I had some issues. Anyway, so I'm very happy to present this paper. Although this is a very, very preliminary draft, as the discussants will have seen in the draft that I sent, mainly because we were hoping to have all the, the results and everything ready by now. Unfortunately, we've had some data connection issues, so I'm actually gonna discuss this at the very end. So this is very preliminary. This is actually the first time I'm presenting this paper, so any feedback is very, very welcome. So this paper is joint work with Guillaume Mollard, who is a senior researcher at Senegal and professor at Polytechnique. And so I'm Gwen-Jirō Clochard, assistant professor at the Institute of Social and Economic Research at the University of Osaka. And so essentially what we're going to talk about today is how to get precise demographic, socio-demographic data in a developing country with regular and precise updating, right? So why do we care about this question? Basically, if you want to do, high, target policies such as healthcare, education, infrastructure, anything that you want to do, you need ideally to have these decisions driven by data, right? And especially high quality population data to make these decisions on where and how to target certain policies, right? And to do so, you need access to up-to-date, very disaggregated data at the smallest level possible with the highest degree of update as possible, right? And as you know, this is a development economics seminar, so I don't think I have to mention this too much. But in developing countries, it's often very difficult to get access to data that is at the same time precise and disaggregated and up to date, right? And usually what you have, like the most precise information, if you can get your hands on this, is usually census data, which are exhaustive by definition, but are very expensive for national institutes to run and only collected very sparsely in time. So for example, in the context we're going to study here, which is Senegal, the census is only run once every decade. Right? So what happens 5 years, 6 years after the census, you might not be, like the data might not be up to date, right? And so what is a solution that we're thinking about in this paper? We're not the first to think about this solution, but is to use mobile phone data. So why do we care about mobile phone data? First, as I'm guessing, all of you know, mobile phones have become ubiquitous everywhere in the world, but particularly, as can be shown in the graphs here, in the last couple of decades, especially in developing countries, right? Where there's a whole leapfrog literature on like developing countries skipping entirely the landline telephones to move straight to mobile phones, right? So basically, in developing countries, especially in Senegal, where the study is taking place, everybody, every adult more or less has access to a cell phone, right? And why do we care about this? It's because precisely, like in contrast to what I said about the census, basically mobile phone providers collect this phone data routinely, right? That's literally their job, to collect this data, and they save and back them up almost in real time, right? So if you could get access to this data, and if you can match and map usage with socioeconomic characteristics, then you could actually almost have indicators in real time of what is happening in the country, right? So you can, if you manage to, again, tap into this data source, and this data source actually contains some information, then you would be able to update indicators, especially between census periods, right? So as I mentioned, the census last 10 years, if you can get a measure, for example, every year, every other year of population characteristics, then that would be really good, right? And so another, important development that we've seen in recent years, other than data, this availability of data, or this creation of data, or collection of data, it's also, we have seen, massive updates in machine learning computational technology in recent decades, and maybe using the latest forms of algorithms, then we can extract even more information from mobile phone data, right? So what is very important, I'm going to talk about this several times probably during the talk, is we need to do these solutions to complement statistics data with mobile phone data in a very careful way, because we need to be able to inform policy, right? That's the goal of this paper, without infringing on citizens' privacy rights, right? The mobile phone data are very protected data, as they should be. So are census data. And so matching the two, as we're going to do in this paper, needs to be done very, very carefully. Right, so as I was mentioning, we're not the first to think about this concept. So of using mobile phone data for socioeconomic characteristics, as early as so a paper in 2015 based on a study that was conducted in 2010, actually, in Rwanda. Basically, Blumenstock and his co-authors so were able to super precisely predict wealth using what we call CDRs, cold DDR records. So essentially, number A called number B at this time from this cell tower. And so using pseudonymized cold DDR records in Rwanda, they were able to map very precisely at a tower level, the level of poverty or wealth. Since then, this has been used in many other contexts, especially to predict wealth. So in Guatemala, Afghanistan, China, Bangladesh, Sri Lanka, this is not exhaustive. It has been done in many, many countries. And actually, it has also been, or researchers have also tried to use these mobile phone data to predict other characteristics, right? So the first proof of concept was using wealth, but other studies have looked at many outcomes, such as poverty, gender, age, income, mobility, etc., employment, etc. So there are many variables in many different countries. And actually, the success of these, what we call proof of concepts, have made it possible to use these tools, these mobile phone data, to actually inform and guide policy. So for example, Emily Icahn and Josh Blumenstock and their co-authors used mobile data, so MPD, mobile phone data, to target poverty, so to target which households were to be considered as poor for a cash transfer program in Togo during COVID, right? So this has been, so some small-scale programs have actually started using these mobile phone data in actual policy, right? But the problem is basically, and what we're trying to do in this paper is try to test the limits of mobile phone data for public statistics, right? So in particular, there are two dimensions which have been shown to be sort of limited, and we're trying to expand here. In particular, the predictions that have been used using mobile phone data, in particular of wealth, have been shown to be relatively unstable geographically, right? So even within a country, geographically, these predictions have been unstable. Furthermore, we also have, it has also been shown by Barrigas and Cabañas, again, that's Josh Blumenstock and his team, and Berkeley, but that some of the wealth distribution, just looking at wealth, especially the ultra poor, cannot be well measured using mobile phone data, or at least in their context, which was 10 years ago or so in Haiti. So another question, this is a question we're trying to address in this paper, is which socioeconomic characteristics can actually be predicted with MPD, with mobile phone data, is still an open question that we try to contribute to in this paper. So what do we do? So we use census data in Senegal, which gives, this is something very specific to developing countries, but the census is huge. There's more than 200 questions that are being collected. And so we use essentially mobile phone data, and we try to see if we can predict these outcomes. And how we're going to do that, we're going to be able, for the first time, to the best of our knowledge, to match at the individual level mobile phone data and census data, right? Because in the census data, or in the pre-census I'm going to mention, the Statistics Agency of Senegal collected the phone number of the head of the household. And so we use that, and we match that with the head of household's mobile phone usage. And then we use very recent machine learning predicting algorithms, so deep learning algorithms, to try to see which socioeconomic indicators can be predicted with mobile phone data, right? And we also do some determinants of predictive capacity. As I was mentioning in the beginning, we plan to do a lot more on this. Unfortunately, we've been restrained by data, but hopefully it will be resolved in the next weeks or so. Right. So what does, let me give you a bit more information of the data sources we use in this paper. So first, the demographic information, so socioeconomic outcomes. So we use the pre-census survey collected by the Statistics Agency of Senegal. This data was conducted in July 2022. So we use the pre-census survey, which is basically the Statistics Agency is rolling out the questionnaire of the survey. The objective is not really to get the data from the survey. Is mostly to make sure that the tablets are working well, that we know how to enumerate certain enumeration areas and so on. But we got access to, they allowed us to have access to this data to conduct the study. So we have about 150 enumeration areas, which is approximately 100 households each. And as I was mentioning, the Statistics Agency collected the phone number of the head of the household, which we're going to then be able to match with phone data. So as I was mentioning, it's about 200 variables for approximately 13,000 households in total. Right, and so we complement this with mobile phone data. So coming from the largest phone provider in the country, and essentially we have for each of the households that are in the database, we collected the data 1 year prior to the survey. So their mobile phone data 1 year prior to the survey. We use their call data record. So essentially that's mobile X, so number X called number Y at this time, this date, from this cell tower. We have all their mobile money transactions, their balance, so how much credit you still have on your mobile, and their mobile data usage, right, if they surf the internet. So in total, this represents approximately 120 million individual lines, right? So one line being like one call from a number X to a number Y. So there is like a lot of information that we're going to process later. Right. As I was mentioning in the beginning, let me just spend maybe 1 or 2 minutes on ethical issues. As I was saying, mobile phone data are very sensitive data, right? And the same can be said, possibly even more so, for census data. So we need to handle these data with the utmost care, right? And be very, very careful, especially when you match these data, not to infringe on privacy rights. So what do we do? Basically, from the very beginning, I think it was the second meeting we had in this project, we started working hand in hand, basically, with the data privacy agency in Senegal, the Commission de Protection des Données Personnelles. And basically, they made the call on every single decision, on every single proposition that we made to ensure that the privacy and rights of citizens were not infringed. So what did we do? We de-identified the data, which means that we encrypted every single phone number. That doesn't mean that the data is completely anonymized, right? Because we still know that a number X called a number Y from this particular cell tower. So if you have sufficient information, you could technically recover the individuals. We wouldn't, of course, but technically it would be possible. So we don't say it's anonymized data and pseudonymized data. Because it's not perfectly anonymized and we can do whatever we want, we decided with, again, the agreement of this the CDP, that the data could only be accessed from the car using blocked IP addresses. There's also a lot of issues regarding sovereignty issues, right? So we don't want to send these data overseas to whatever country, whether it be it France, where Guillaume is based, or Japan, where I am. And it could only be accessed, again, from the car by a very, very small team of accredited members, right? So every single team member had to be accredited. And that was super important. It was also one thing I didn't put on slides. All the code was supposed to be and can be audited by both the phone provider and the statistics agency at all times, right? So they can audit the code at all times to check that we're not breaking any of the rules that we said we were going to follow. Right. So I'm going to go very quickly because I'm running a bit out of time. So on preparation of the data, usual cleaning for demographic data. I'm not going to spend too much time on this. For mobile phone data, we use the method developed by, again, the Berkeley team with Emily Eichen and co-authors. Basically, the idea is that you move from raw data, which is, again, one line is number X called number Y at day T time D time T from cell tower T. So we use all of this data to create essentially features that is like one row per phone number. That is, number of calls, average durations, etc. Sort of behavioral patterns based on your calls. So in total we get a bit more than 1,600 features per phone number, and then we're matching at the individual level, and then we're running some algorithms. We use a validation model, so we're going to use some machine learning framework. So we use a validation model with 120 areas as a training sample, 29 enumeration areas as an evaluation sample, meaning that we test, we calibrate the algorithms based on these training samples, and then we test on the evaluating samples on the data. We use many types of algorithms. I'm not going to get into too much details. What we use for quality of prediction, this can be up for debate. I'm happy to discuss this, why we use this one instead of AUC or other variables that can be used. We use the R squared of the average of the variable at the enumeration level area, right? So the algorithms are going to give us a prediction per phone number. And what we're going to use as outcome is basically we're going to aggregate those at the enumeration area level and then run a regression for the evaluation sample on the the predicted value of this average on the actual level of this average across the enumeration areas. So what do we find? First of all, we find a lot of heterogeneity in the capacity to predict socioeconomic outcomes. So in particular, what we find is that 50% of indicators overall are not predicted at all, right? So that means that the R squared in the enumeration area, which again is not bounded by 1 as standard R squared, but is basically 0 or lower, right? So about 50% of indicators, there's nothing in phone data that can help predict those. However, you have some indicators, some socioeconomic characteristics that can be predicted with very high precision, especially given the limited sample that we have, with sometimes the R squared being well above 0.5, right? Again, the R squared on a validation sample, not on the training sample. What is quite interesting is that 5 out of the first 12, but 3 out of the 10 most predicted outcomes were actually used in the first papers to predict wealth, right? Indicating that, I don't know if it's luck on their side or something, but wealth is something that can be potentially very well predicted in this. So then what we try to do, and again, we've been a bit limited on this front due to data access. We try to disaggregate, we try to understand basically what is driving this heterogeneity between outcomes that we can predict or not. The first thing that we thought of doing, which is the natural thing, is to compare what category is it that we're trying to predict. So we have 3 main categories of outcomes. What type of agriculture is the household producing? What kind of so demographic information, so the gender of the household, etc., number of people in the household, etc., and possessions. Do you have a fridge in your house, etc., things like this. And what we find is that we have lower predictive capacity for agricultural variables. So we do find lower capacity, but we find no statistical difference between demographics and possession. However, as you can see on the graph here, what we do find is that some variables are not predicted, some variables are well predicted in each category. So, right, so it's not just about if it's agriculture or demographics or possessions. It seems that there are something even within these categories that seem to matter. And so the final graph that I'm going to show you today is, so another thing that we're trying to vary is basically to look at is basically the type of, like, the statistical characteristics of the variable. And in particular, why do we care about this? It's because we know that to train models, you need to have some variance, right? If everybody in the survey is saying that they're not cultivating a specific type of grain, then of course we're not going to be able to predict who is saying yes, because nobody says yes, right? So, and what we find in this graph is that basically variables that do have some variance are much more better predicted, but again, some of them still are not predicted. Right, I'm going to stop there. The only thing, so I'm not going to repeat what I've been saying because I'm running out of time, but what I'm just going to say is that super strict regulatory framework is very important when you want to conduct these projects, and building trust between institutions where researchers, there's a statistics agency, and there is private operator. This is really tricky, and so you need to proceed with caution if that's something you're interested in. Thank you very much.
Yes, thank you, Gwen-Jirō, for another excellent presentation and the perfect timekeeping. So now we have about 10 minutes left for our Q&A session. So again, our discussants, you can start with your comments, questions. Probably we keep the same way. Jean-Baptiste, if you want to start.
Okay, so thank you very much, Gwen-Jirō. This paper is, I really like the conclusion of this paper, in fact. The importance of the census indicators, even with the mobile phone data. So in your presentation, you are talking about this external validity problem already existing in the literature, but the idea is that a lot of the results with the mobile phone indicator is that it's context dependent. And I think that the paper should say more explicitly what is structural, if you can, versus what is Senegal Sonatel specific, but maybe a little bit more discussion about that. Also, maybe in the manuscript, you can talk about the operator selection issue, because it was not clear for me, because you have 10,000 individuals in your sample, but all these individuals are Sonatel clients, or is it other clients? I'm not sure about that. Also, I think the paper would benefit from a sharper discussion of what is new relative to Blumenstock work, precisely because the data are richer than standard CDR only designs. For example, in your data, you have mobile money, recharge histories, and mobile data usage, instead of relying only on calls and SMS. So what could be interesting is to compare the different indicators you have depending on the number of data sets you are using. For example, the CDR only, or CDR and recharge, CDR and mobile money, or maybe it can be interesting to have this kind of of different indicators, and maybe the reader can understand whether the gains come from the scale or from newer forms of digital trace data. Also, maybe I don't have any time left.
Yeah, 1 minute.
Okay. The modeling strategy is powerful, but still somewhat black box. This is, of course, because you are using deep learning method. But I think you can maybe give some examples of some indicators, some mobile phone indicators that influence the quality of in fact what are the main mobile phone indicators that influence the quality of your results, because I think that the objective of the paper is to inform the statisticians and etc. So maybe it can be interesting to have some examples about that. Yes, that's it.
Thank you, Jean-Baptiste. Maria?
Yes. Can you hear me?
Yes.
Okay. Perfect. Yes. So also I want to join the congratulations on the paper. I find this very cool. I guess I should say for warning, I know very little about deep learning methods, so my comments will be of a different style. I guess the first one is a little bit on the selection into the sample, right? So you start from over 13,000 pre-census households, and then you end up with about 10,000 and those are the ones whose head of the household you can attribute the phone number to. And there are different reasons that you mentioned on why there are exclusions. No, some of them is, well, the number is a neighbor, is somebody else, the head has no phone, etc. So precisely from a policy targeting perspective, I was worrying a little bit whether these households that were excluded might be actually the ones for which we have the least data on policy targeting, because they are the poorest of the poor, they are the ones living in the most remote areas, are these like female-headed households. So trying to understand a little bit what are the characteristics of those who end up in the sample versus not, I think might be important to understand a little bit how useful this exercise would be for policy targeting in this context. The second comment is about what I was saying about my ignorance on the topic. So, you mentioned you built all these features, 1,616, based on the mobile data. And, I felt like, oh, this is a lot. But then I at the same time, I felt, is it? I don't know, right? Because I don't know how this fits within the literature. So I think a discussion a little bit on that would be helpful. Are these the features most commonly used? Which ones have been shown to matter? Are there any that you actually don't have that have been shown to matter for the literature? I have no idea, but I was wondering while I was reading this. Also related to the machine learning exercise, on the validation model, you mentioned that you use 80% of the enumeration areas as the training sample and 20% of the evaluation sample. I suppose that there are robustness checks that are done on these things, and I think that would be quite helpful to understand, so that it doesn't sound a little bit like cherry picking exactly using that threshold. And finally, going back to the policy question, I understand that the usefulness of the exercise, to use mobile data to try to target policies whenever we don't have other better sources of data. So I think, if I understand correctly, you could try to do some counterfactual with this data, so that you could try to imagine, okay, what if the government wanted to reach with a policy the 5%, the bottom 5% of households by income level, for example? How would using the different methods change? How would households be ranked? Type 1 error, type 2 error, like those type of things. I think you could do it with a counterfactual exercise, if I understood correctly. And yeah, thank you so much, and congratulations.
Thank you, Maria. Sam?
Yeah, thanks. So again, sort of just many of my comments have already been covered, so I won't sort of repeat them, although I can send you them afterwards. I think what I really felt when I was reading this paper is it's a very ambitious paper, and it's kind of, again, quite impressive. But I think it lacks a bit of focus. So, you have all of these outcomes, you have all of these features, you have all of these methods that you're using. So at times it really feels like you need to focus on a smaller subset to be able to say something more nuanced than what you currently do. And in particular, just one example would be when I was looking at the features, I was saying, well, some of these features feel like, to me, they'd be more informative than others. So is there any way for you to look at which of these features matters more for prediction than others? And do you use them all in one go, or is it just that level of detail wasn't very clear in the paper? So I think just kind of sharpening the focus a little bit would really help the reader. Just looking, I think most of my other ones have been covered, but I think I guess the policy implication for me, so again, I think it's quite ambitious, is the idea that we can use this data's collected much more granular data, we can almost use it in real time and so on. But is it realistic to think that we could actually scale this exercise up, especially given the privacy issues, but also presumably the commercial nature of the data? So, often when we use these sort of large scale data, it's often publicly available data, which presumably is not the case when it comes to mobile phone providers. So how feasible is it that in practice, even if you could work out how this would work, that it could actually be used by policymakers. So I think that probably needs a bit more convincing of the reader. But yes, I think most of my other comments have kind of already been covered.
Yes, thank you. So Gwen-Jirō, you'll have a few minutes to respond to any of the comments, questions.
Right. Thank you very much to all three of you. These are super good comments. So some of the comments we actually wanted to do them again. Like we ran into some data access issues, so we that should be resolved hopefully in the next few weeks. But so particularly one thing that I want to, so two things I want to focus on perhaps now. So first is on the selection into the sample that I think both Jean-Baptiste and Maria mentioned. So as you probably realized, this was already a huge exercise to try to get these people together, have different objectives, the statistics agency, the phone provider, the data privacy issues. Our agenda might be a bit different, right? So trying to make everybody converge was a bit different. We had initially discussions with other phone operators in Senegal to try to see if we could actually implement, all of them, like something with all of them at the same time. We decided against that for now, right? So we only use this main operator for now, for practicality issues, but also for privacy issues, because it was very difficult to get, so to convince all the actors to put the data on the same server, right? The phone and the census data, but to have data, because the data format also can be a bit different between operators and so on. Trying to have both, like two or more operators in the same, database would be really challenging in terms of competition issues, right? So that we do acknowledge. What we try to do, again, I don't have the data because we couldn't extract this in time, but we try to do is try to compare the households. So we have the census information for these 13,000 households, and we're able to match these with something like 10,000 households with the mobile phone data. What we try to do is an exercise where we try to see if those households are different in characteristics with the one that we're not able to match. And there are some differences. I don't have them in top of my mind, but there are some differences that we try to explore, and we're actually thinking of how we can incorporate these and the missing households into the data. So that was the first point, maybe discussion of which features might be important, etc. We want to do that. We have some preliminary graphs that I'm not showing. I haven't shown you today, but we have some preliminary results on this. But this is like too preliminary to show for now. But we are thinking about this to try to see is, do we have like one feature that predicts every, or is it like super spread out across different outcomes? That's something we're trying to do. And just very quickly on the policy implications of what we can do with this data, what we're actually trying to do right now is trying to understand, again, like how we can incorporate this. So this is one block of a many blocks program that we're developing with Senegal Statistics Agency and this phone provider, maybe other phone providers at the moment. We are also looking at how we could target, as I think Maria mentioned this. So could we target could we target individuals based on these issues? This has already been done a little bit in Togo, as I was mentioning earlier. But we're also trying to see what we could do with this data. So that's, we're also trying to focus on, some specific outcomes. Specifically, apparently, the statistics agency is very interested in agriculture. So we're looking at agriculture. Agriculture has two very important or interesting features. First of all, I mean, it's very important for food safety in the country. So that's, it's very high on the priority list. But also, we have data on many different crops that households might be growing. And these many different crops, what is interesting is that they might have different, cyclicalities, number of harvests, etc., which actually might be reflected in the patterns, in the phone data patterns. And we're trying to see now is if we can actually create some, data set on, this crop is grown every 3 years. Oh, sorry, twice a year or 3 times a year. So we can actually see that in the data, and we should actually predict better this outcome based on the phone data than other stuff that is maybe once a year or something. So that's something we're trying to incorporate right now. So thank you very much again, everyone, for your comments. These are great.
Yeah, great. So looking at the clock, it seems we are just about out of time. If we probably in the discussion, we had 2 points, one from Stefania Lovo for Anshika. She says, in case you haven't yet done so, you could perhaps also explore heterogeneous effects by pre-existing gender norms. And Virginie Comblot, she asked Gwen-Jirō about the respondents if they gave their consent for the use of their mobile data, the thing that you partially explained during your presentation. I don't know if you want to add a word on that.
So, very, very briefly. So this is super important, important point. So we work. So the Statistics Agency of Senegal has the legal right to use data and to match the data using. So they have the statistics law of Senegal allows them to do that for public statistics purposes. So they have the authority to use these data that they collect during the census. Because we know that this is a very sensitive issue, this is part of the reason why we used pre-census data and not the actual census data that are going to be, the statistics are going to be reported and so on. But this is something that we worked, we had many meetings with legal departments of the Statistics Agency, the phone providers, and the CDP, the Protection, the Privacy Commission people. And in the end, we all agree that the infrastructure we're using now is in accordance to the law, and to the what is it called? The Conditions Générales de Vente. I forgot the name in English. The terms and conditions, sorry, of the phone provider that they have with their clients.
Okay. Yes, thank you. Well, I think Anshika has mentioned, saw your comment, Stefania. So, yeah, so let me extend my thank you to both of our speakers for sharing your research here. And a huge thank you also to our discussant for the great work and comments you provided, and also for the participants for your time for joining us. So thank you, everyone. And let me mention our upcoming webinar, which is scheduled for May 19. And yeah, you can join us for a roundtable on careers in international organizations. And the session will offer insights into what employers are looking for and what successful professionals have to say about their careers. So yeah, we will welcome 2 colleagues from World Bank, from the IMF and FAO. So yeah, this is for our next webinar. And yeah, let me conclude. Thank you again, everyone, and have a wonderful rest of your day, everyone. And yeah, goodbye.